Hello everybody, it's Mrs. Avon. In section B, we are going to look at acceleration and circular motion. In section A, we talked about speed and velocity. So the next logical question about something moving in a circle is an object moving in a circle with a constant speed accelerating? And in order to answer that question, what you need to know is the definition of acceleration. And when an object is accelerating, it is changing its velocity. Not necessarily changing its speed, but changing its velocity. So we know for uniform circular motion that speed does not change. However, because the direction is changing, if you're moving in a circle, your direction is constantly changing, that means you're accelerating. If we remember back to the first motion equation, Vf equals Vi plus At, we rearrange it, that gives us our definition of acceleration, a change in velocity over time. However, when we are in a circle, we can't use a linear equation. So if we want to calculate the magnitude of the acceleration, we use circular motion equations, which would be the velocity squared divided by the radius. Because the velocity is 2 pi r over t, we can substitute that into the equation, so we have two different ways to find acceleration. Those equations are identical. V squared over r is equal to 4 pi squared r over t squared. All we did was plug in our equation for velocity that we learned in the last section, which is 2 pi r over t. So in the sublevels, you're going to be asked questions about relationships. Remember that if something is in the numerator, it has a direct relationship. So acceleration is directly related to the radius. It is inversely related to the square of the period. So when they're asking you if I double the radius, that would double the acceleration as long as I keep the period the same. Whatever I do to the period, the opposite will happen to the acceleration. So if I increase the period, the acceleration will decrease, and vice versa. Since we are talking about acceleration, we also have to talk about its direction. And the direction of the acceleration we can figure out two different ways. The first way is through a little bit of geometry. We know that the velocity of an object moving in a circle is always tangent to the circle. So I have the initial velocity and the final velocity between points A and B. I'm just picking two random points. When we add vectors, we know the number one rule is that they have to be added tip to tail. So if I take Vf minus Vi, we talked about this very briefly when we did vectors. If you are subtracting a vector, we don't really subtract vectors. So we would say Vf plus negative Vi, and in order to make a vector negative, we simply switch its direction. So I have a Vf and a negative Vi, it's just in the opposite direction. When I add those together, using essentially the graphical method tip to tail, I'm left with delta V. And delta V is pointing to the center of the circle. It's pointing inward. It doesn't matter which 2 points I pick on this circle. If I find the change in velocity, that vector will always be pointing inward to the center of the circle. You can look at that experimentally. If you just search YouTube and you look at centripetal acceleration, they show you where they put a flame, a candle, inside of like a glass cylinder, and they spin it really fast in a circle, and you can actually watch the flame point to the center of the circle. You can do the same thing if you put a board with 2 water jugs on a merry-go-round. If you spin it around very quickly, these are just corks that are suspended by a string, they will actually point to the center of the merry-go-round. So the acceleration is always directed inward. Another question, since we're talking about acceleration, is if there is an acceleration, is there a force acting on the object? Well, again, if we remember Newton's second law that says F net equals ma, if there is acceleration, there has to be a net force. How do I know there's an acceleration? Because the object is not moving in a straight line. We call this force the centripetal force, P-E-T-A-L. We'll talk more about that in the next video. To find that force, again, it's the same equation for Newton's second law. F net equals ma. We can substitute in for a, v squared over r, or we can substitute for pi squared r over t squared. Those are the same equation 3 different times. It depends on what information you have. So if you had mass and acceleration, you can easily calculate the net force. If you didn't have the acceleration, but you had the velocity and the radius, and so on. So these equations are all identical. Again, they're going to ask for the relationship. F net is directly related to mass and the radius, and I don't talk about the constants because they don't change, and it's inversely related to the period. So it's important not only to be able to identify the equations, but to also be able to interpret them based on how the variables affect each other.